In this video, we will derive the relationship between linear velocity v and angular velocity omega. So consider a particle which is performing circular motion in the anti-clockwise direction. So can you see a figure? This is a circular circle. A particle here is going to perform a motion in the anti-clockwise direction. So that's the reason I'm denoting this arrow. So a particle is performing circular motion in the anti-clockwise direction. Now this particle, which was initially at this point A, is now going to move to this point B. So the particle is moved from A to B. The particle moves from A to B in time delta t. Now delta t basically means change in time. Now this delta t is very small. So when the particle is moving from A to B in time delta t, this delta t is very small. Therefore I am writing delta t is tending to 0. Now since delta t is tending to 0, delta t is very small. If you carefully see this, can I say this AB is more or less a straight line? This AB is more or less a straight line in linear displacement. So this AB is more or less a straight line provided your delta t is very 0. So when the particle moves from A to B, I can say AB is a straight line. At the same time, at the center, there is an angular displacement delta theta. At the same time, at the center, there is an angular displacement delta theta. Now we know the value for instantaneous linear velocity. Now since we are using instantaneous, we know we have to use limits. The formula for velocity, linear velocity, is linear displacement upon time. So I write limit delta t tends to 0. Why? Because we are talking about instantaneous and we are writing linear displacement, which is nothing but delta s upon delta t. Again I am saying delta s basically means change, but since we are limiting the value of delta t tending to 0, this change is very small. Now we know this is the relationship between angular displacement and linear displacement. So angular displacement is equal to linear displacement upon the radius. Therefore I can say linear displacement is radius times the angular displacement, or delta s is equal to r delta theta. So instead of the delta s out here, I can put r delta theta. So instead of this delta s, I will be putting or substituting r delta theta. So when I do that, I will get limit delta t tends to 0 as it is. Instead of delta s, I have substituted r delta theta. So I am writing r delta theta upon delta t. Delta t is going to remain as it is. Now since this radius is a constant, we don't take a limit of a constant. Remember this if you are a non-mathematics student appearing for NEET or any medical examination, that your radius is a constant, so that is not going to be a part of a limit. So you take this radius outside. You write limit delta t tends to 0, delta theta upon delta t. Now you can call this entire as angular velocity, or I could say you can call this entire as instantaneous angular velocity, because the formula for instantaneous angular velocity is first limits, because it is instantaneous. Angular velocity basically means change in angular displacement upon time. Therefore I am writing limit delta t tends to 0, delta theta by delta t as what? Omega. So instead of this entire bracket, I can use omega, and your omega is nothing but your angular velocity, or rather I would say instantaneous angular velocity. So when you substitute this, instead of this I am putting what? Omega. I am going to get the result v is equal to r omega. V is nothing but linear speed. So linear speed is equal to radius multiplied by angular speed. This is the scalar form v is equal to r omega. This is the relationship between linear velocity and angular velocity. If I want to write down in vector form, I write this as V bar is equal to omega bar cross product R bar. Now we all know why cross product, because omega bar is a vector. Why omega bar is instantaneous angular velocity, which is a vector. R is radius, which is also a vector, because we had discussed in the previous videos here radius is going to be a vector. And the answer you get is linear velocity, which is also a vector. So whenever your answer by multiplying two vectors is a vector, you call it a cross product. Therefore, in the vector form, we write V bar is equal to omega bar cross R bar. Now we will look at another method of proving the same thing. We are going to prove again V bar is equal to omega bar cross R bar using another method. Now we know the relationship between linear displacement and angular displacement is linear displacement is equal to angular displacement times the radius. We have studied this in previous videos where I've told you the relationship between linear displacement and angular displacement. So delta S bar is equal to delta theta bar cross R bar. Now, if I divide both these sides by delta t, I am dividing both the sides by delta t. So I'm going to divide delta S bar by delta t. I'm going to divide delta theta bar by delta t. But I'm not dividing R bar by delta t. Now why I am not dividing R bar by delta t is because my R is the radius vector and the radius vector is constant. And that doesn't change with time. So there is no point in dividing your R bar with delta t because it is going to be a constant. It is not going to change with time. Now we are going to take limits on both the sides. So if I take limits on both the sides, they become instantaneous, because we are going to speak about vectors here, and the vectors are true vectors only when we take instantaneous values. Therefore, we take limits on both the sides and I limit delta t tends to 0, delta S bar by delta t is equal to again limit delta t tends to 0, delta theta bar by delta t cross R bar. Now, we know this limit delta t tends to 0. Delta S bar by delta t is the value for instantaneous. So there's another way of representing instantaneous values. Instead of using limits, I can use derivatives. So if I use derivatives, instead of delta, I will use d. This limit is not going to be there. So it's going to be delta S bar by delta t. And this is going to be delta theta bar by delta t cross R bar. So this is nothing but another way of representing this, because in instantaneous values, there are two ways to represent. Either I can use limit delta t tends to 0, delta S bar by delta t, or I could use this ds bar by dt. So either I can use limits or I can use derivatives. Now we know this ds bar by dt is called as v, linear velocity. How? Because your linear velocity v is change in linear displacement upon time. S stands for linear displacement and d stands for a small change. So I will say small change in linear displacement upon time. Similarly for omega bar, which is your angular velocity, I am going to say small change in angular displacement upon time. So d theta bar by dt is equal to what? Omega bar. So instead of this entire derivative, I can use v bar, because v bar is nothing but ds bar by dt, or change in linear velocity, very small change in linear velocity with respect to time. And instead of d theta bar by dt, we can use omega, because omega is change in angular velocity upon time. So the entire equation now is going to become v bar. Instead of this, I am writing v bar. Instead of this, I am writing omega bar cross R bar. So this is another way of proving the relationship between linear velocity is equal to angular velocity times the radius. Hi. In this video, we will understand and discuss what do you mean by the word periodic motion. It's very simple. Any motion which repeats itself. So a motion which is repeating itself after equal intervals of time is called as a periodic motion. Let me elaborate this. Any motion that repeats itself after equal intervals of time, which means I go for morning walks. So if I go to a garden and I take 10 minutes to complete one round, So after every 10 minutes, I'm repeating the same motion. I again repeat, I go to a garden for a morning walk, and after every 10 minutes, I finish one round. So after every 10 minutes, I am repeating the same motion. So my motion turns out to be a periodic motion. Take an example here also. You have a car race going on. So this car is going to just go around this lap again and again. So this lap is covered by this car in 2 seconds. So every 2 seconds, the car is going to repeat the motion, right? Every 2 seconds, this car would go on the same track. So after every 2 seconds, the car would repeat the motion. So it would take 1 lap in 2 seconds. Therefore, it would take 2 laps in 4 seconds, 3 laps in 6 seconds. Therefore, I will say the motion of this car is periodic. So periodic motion basically means the motion which is repeated after equal intervals of time. So whenever your motion is repeated after equal intervals of time, it's called as a periodic motion. Hi. In this video, we are going to understand what you mean by UCM, Uniform Circular Motion. So first of all, understand this is a circular motion, and we all know in a circular motion, the object is going to move along the circumference or the boundary of the circle. So whenever the object moves along the circumference or the boundary of the circle, we call such an motion to be a circular motion. So let's take a body like car performing circular motion. Now, whenever the speed of the car, I would say the linear speed of the car is constant, you say your body is moving in uniform circular motion. So this car is going to move along the circle with a constant linear speed. Example, since it is speed, so please don't focus on the directions. We are just going to focus on the fact that the speed is constant. So it is a scalar, it's got no direction, and the speed is constant. Let's say, for example, the speed of this car performing uniform circular motion is 20 kilometers per hour. So this is the constant speed of this car performing uniform circular motion. Point number one, this is the point number one you need to remember for uniform circular motion. That any body which is performing uniform circular motion will have a linear speed constant. When I say constant, this means the speed of the car along the circle is not changing. It's fixed. Example here in this case is 20 kilometers per hour. Second, you need to focus on the velocity part. Now we all know velocity is a vector, and vector basically means it's going to have a direction. So to show this direction, we draw a tangent at that position. So if I have a car here at this position and I want to show the velocity of this car. Now velocity is similar to speed, but speed has got no direction. Speed has got just a value like 20 kilometers per hour. But velocity has a direction. So I have to draw a tangent at this position. So let's say at position A, I draw a tangent. Now the car is going to move from position A to position B. Now the car has moved from position A to position B. Now at this position, again, if I want to show the velocity, I have to draw a tangent at that position. So if I draw a tangent at that position, can you carefully see at position A, the tangent was pointing upwards. At position B, the tangent is pointing towards the left. So at position A, it is pointing upwards. At position B, it is pointing towards the left. Therefore, the direction is changing. And if the direction is changing, obviously the velocity is going to change. Because for velocity, their direction is important. Here, I would define the velocity to be 20 kilometers per hour in the upward direction. Here, I would define the velocity as 20 kilometers per hour in the left direction. So the velocity's direction keeps on changing. So whenever you have a direction of the velocity which is changing, obviously you know whenever the velocity changes, you call it acceleration. But still remember the magnitude of this is not going to change. This 20 kilometers per hour, whether it is in the upward direction at point A or 20 kilometers per hour in the leftward direction, 20 kilometers per hour would remain the same. And we know whenever the velocity is changing, you call such a motion to be accelerated, because the definition for acceleration says change in velocity upon time. So whenever your velocity is changing, even though the number is fixed, but the direction keeps on changing, therefore I say this motion is accelerated, and I say uniform circular motion is accelerated motion. So I have to remember two important points. Point number one, in uniform circular motion, you have constant linear speed. When I say constant linear speed, the speed of the vehicle is not going to change. It's fixed, it's 20 kilometers per hour. But the velocity is changing because the direction is changing. And how do you denote the direction of the velocity? You just denote the direction of the velocity by drawing a tangent. So the direction keeps on changing. Therefore, I say uniform circular motion is accelerated motion. Now, next thing I need to remember is this uniform circular motion is periodic because it repeats itself after equal intervals of time. Can I say in this uniform circular motion, the car will start at A, move a circle, let's say in 2 seconds, again come back to point A, again move a circle, again come back to point A. So after every 2 seconds, the car is going to repeat the motion. So since car is repeating the motion after equal intervals of time, point number 3 to be remembered in uniform circular motion is periodic. So 3 points were important. One is uniform circular motion has got constant linear speed. Second, uniform circular motion is accelerated motion. Third, uniform circular motion is periodic in nature. Now, understand uniform circular motion in terms of angular speed. Now, previously we were talking about linear speed S. Now we are interested in talking about the angular speed, and I know the angular speed is omega. So let's say I make a statement that the angular speed of a body performing uniform circular motion is constant. So if I say it is constant, I can say speed is distance by time. Now time will definitely change, right? But the distance covered in that time will not change. If let's say for an example that this body which is performing circular motion here covers 2 meters in 1 second. How much it is covering? 2 meters in 1 second. Now we'll draw this visually. Now let's say initially the car is at point A. In the first second it reaches point B. So from A to B the time required was 1 second, and we know that this distance is 2 meters because the speed of the car is constant, that is 2 meters per second. Now at this time, what is the angle covered? The angle covered is 90 degrees. So from A to B, it took 1 second. The distance was 2 meters and the angle covered was 90 degrees. Now, let's say the car at point B is now going to move to point C. So in next 1 second, the car moves from point B to point C. It took only 1 second for the car to move from point B to point C. Again in 1 second it covered 2 meters and the angle again was what? 90 degrees. So can I say the angle covered by the car was a constant one? So the angle covered by the car was constant. It was covering 90 degrees in every second. In the first second it covered 90 degrees from A to B. In the next second it covered 90 degrees from B to C. So the angle covered was a constant one in uniform circular motion. Therefore, I am going to say my theta by t was constant. It was 90 degree per second. Now, if I, instead of using theta, if I use radians, instead of using degrees for the angle theta, if I use radians, I get radians upon second. Now, radians upon second is nothing but a unit for angular velocity or angular speed. Therefore, my omega is equal to theta by t, which is 90 degree per second, or I could say pi by 2 radians per second, and this omega is constant. Therefore, I say uniform circular motion has constant angular speed. Your uniform circular motion will have constant angular speed. Now let's come to the mathematics part of it. Let's say you have a circle. A body starts at point A. After 30 seconds, after body starting at point A, after 30 seconds, it finishes one revolution. Now when I say it finishes one revolution, the body started at A, it moved all the way and it came back to the same point. And how much time did it take for it? 30 seconds. So 30 seconds was the time taken for one revolution. Again, when it comes back at the point A, now we will call it destination B. So a body starts at A, takes 30 seconds to take one rotation and then comes back to point B. Now this 30 seconds is called as the period. What is this 30 seconds called as? Period. And period, obviously it's time, so its unit is going to be in second. And this period is the time required for one revolution in uniform circular motion. So what is a period in uniform circular motion? It is the time required for one revolution in uniform circular motion. Now we all know this formula, speed is equal to distance upon time. So if I want to apply this formula here, I know the time is 30 seconds. Can I say the distance covered by the circle is nothing but the circumference of the circle? And the circumference of the circle is 2 pi r. So if I want to calculate time, I can just say time up, speed down. And I know the distance covered by the circle is equal to the circumference, and that is 2 pi r. So I get the first formula as 2 pi r upon the speed. This is the first formula I get for time period, and time period is the time required for one revolution. Now I know this formula, V is equal to r omega. So instead of V out here, I can put r omega. So when I substitute r omega here, 2 pi r will remain as it is. Instead of V, I will put r omega. This r will cancel out. And I will get the next formula for t. T is equal to 2 pi upon omega. So I have two formulas. First, t time period is 2 pi r by speed or velocity. Second, time period is equal to 2 pi upon omega. Now third, let's understand the meaning of the word frequency. Now frequency is number of revolutions in 1 second. Now let's say I have a car which is rotating in a circular motion and it makes 6 rounds in 1 second. I'm talking about a toy car. I'm not talking about a real car. So let's say I have a toy car which I am controlling using a remote and it's covering 6 revolutions in 1 second. So that 6 revolutions basically is your frequency. So it's the number of rotations or revolutions covered in 1 second. So I have a car at point A. It's covering again 6 revolutions, as I said, every second. So this frequency is denoted by symbol n. So this n is the denotation for frequency. Now remember, frequency has a formula 1 upon the time period. So whatever were the formulas for time period, we'll just take the reciprocal of it to get the formula for frequency. So n is equal to 1 by t. Now 1 has got obviously no unit, it's a number. T is time, it's got unit second. So I have 1 by second, which when I take it up becomes second inverse. This is the unit. Now this second inverse is also called as hertz. Remember this. This second inverse is a unit which is also called as hertz. Now we know this formula, T is equal to 2 pi upon omega. Now if I want to find out n ka formula was 1 upon t. So instead of this t, I can put 2 pi upon omega. What's the formula for n here? 1 upon t. So instead of t, I can put what? 2 pi upon omega. So I write n is equal to 1 upon 2 pi upon omega. Now this basically means division. So I write 1 divided by 2 pi upon omega. And I know by division gets converted into multiplication if I take the reciprocal. So if I take the reciprocal, it becomes 1 into omega upon 2 pi. So n is equal to omega upon 2 pi is another formula I have. Now, we also know V is equal to R omega, right? V is equal to R omega. So I can take this R down and I can say omega is equal to V by R. So in this formula, I am going to substitute instead of omega V by R. So instead of omega, I am going to put what? V by R. So when I do that, I get N is equal to V by R of 2 pi. This is nothing but, instead of omega, I am putting what? V by R. So I get V by R of 2 pi. Now this is nothing but 2 pi R. So I get another formula for N, which is equal to V upon 2 pi R. That's a formula for frequency. Now I also, from this formula, if I want to find out omega, I can say omega is equal to 2 pi upon T. Right? If I take this omega up, T down, I can say omega is equal to 2 pi upon T. At the same time, I can just split this and write 2 pi into 1 by T. Right? I can do that. I can just split this. I can write omega as 2 pi into 1 by T. And I know 1 by T is what? N. So instead of this 1 by T, I will put what? N. And I will get omega is equal to 2 pi N. So I get a formula for omega, which is nothing but 2 pi N. I suppose everyone knows omega is angular speed or angular frequency. 2 pi is constant and N is just frequency. So omega is angular speed or angular frequency and your N is just frequency.